Hey, what's up, peeps? Alright, quick video. So, I got this. This is a knife. I don't think I've shown really a done one on video. It's not done, but, so yeah, that's the blade I milled in that video I posted, like, yesterday, I think? Yeah, which was Sunday. But, this is how it turned out. That's hard milled, pretty nice. There is one glaring issue, and I wonder if you can figure out what it is. That's right. The bevels don't line up, and I figured out why. The blade is 10 thou, undersized, so that would obviously cause this side to be shorter. See this line right here? Compared to this, oops, this side. So yeah, see, this is what it's supposed to look like. Very nice looking, you know, look at that surface finish. But yeah, and then, yeah. So anyways, we're going to work on the lock bar. I don't even know if I said that already. That's what the lock bar insert looks like. It is very tiny. It is a pain to make quick fixtures for. So, yep, there's this over travel tab built in. There's a countersunk hole in the middle. There's a board hole to locate onto the bottom handle, which kind of looks like this. It's its pocket right there. That's the board it needs to locate to. So the fixture I made works really good, or it works pretty good. And yeah, I just wanted to go over kind of the fixture and like how I machine them, because I think maybe it'll help somebody in the future, because there's definitely no tutorials on machining a lock bar insert. That's pretty niche-y, if you will. Okay, not sure where to start. Let's just go into Fusion then. Welcome to the technologically advanced in-screen recording. I know, not a staple of the channel, but here we are. Alright, so, sorry for the buzzing, that's the phase converter. This is the fixture that is sitting on the table. Well, this is at least the removable plate. And so we're just looking at the lock bar section for now. So for op 1 of the lock bar, what I do is I buy a 1/4 inch by 1/2 inch, no, 1/4 inch by 1/4 inch, 17/4, I think it's annealed is the state it would be in, stainless. So that's what the lock bars are made out of. And then, so what I do is I take, or we have a 1/4 inch by 1/4 inch square stock, so that's what I'm using for the stock. What I do is I take the bar, oh sorry, it's 1 inch by 1 inch and a 1/4 inch high, that's what I meant. To cut the bar, then I heat treat just individual cut bar, and then what I do is I take the heat treated, that 1 by 1 inch square, put it in the fixture, and we have I want to say this is a pit bull, but someone's going to correct me if I'm wrong. Hold on, let me check. Yeah, okay, it's a Mighty Bite pit bull, and the number is 26060. So that's what I'm using to actually hold that little piece of stock in, and machining this in the vise is kind of difficult because you can't clamp and machine this part with enough distance, and vices are not a sustainable production ready method. So put the stock in, adaptive out the stock, then we're going to adaptive just the top. That we're leaving stock to leave on that adaptive, so we can do a horizontal and clean the top up. Come in here and do a contour, and I just come close to this block here, and that way this block is permanent. It's a piece of chromoly that stays in place, and I don't want to hit it, so we come really close and leave a little sliver, and I'll tell you what we do with the sliver in a second. Finish adaptive with the 60 thou, or 1/16 end mill. Contour. I'm currently leaving stock on the back side here because this is the section that touches the tang of the blade. So we're leaving 5 thou here. Go ahead and scallop that counterbore. Not sure if that's the best way to do it. Bore all the way through the stock, and the reason we do this is because we use the hole all the way through the stock to locate for op 2, and I'll talk about that. Final scallop with an 1/8 inch to clean up that counterbore, then chamfer, and I am actually using the chamfer to cut the entire chamfer. It leaves a really nice surface, and then just outside deburr for op 1. So that's all good. So what we're left is with, excuse me, is this block with this part sitting in the block, and I'll show that in person in a second, or we'll go over that. So we take this block, and what we'll do is we'll flip it over, and it'll fit in this pocket all nice and snug. Then, so this is going to be op 2, work offset changes to that center bore. If you have your work offset, your first work offset doesn't matter that much as far as accuracy goes, because you're cutting out a raw stock. What matters is your next work offset, or your next offset, needs to be dead nuts where you want your things to be. You kind of need a precise locating fixture for op 2. That's kind of the whole point. So what we do is we take that piece of stock from op 1, flip it over, we run 440 bolts through those board holes I told you about that are these right here. So what we have is stock with these 2 bolts sticking up. So what we'll do is we'll adaptive the entire block, and that burr I was telling you about that is left from this contour in op 1, there'll be a burr right here. I cut a pocket here, so you flip it over and the burr doesn't matter because the burr will sit in this pocket. Adaptive out with a 3/16 bullnose, horizontal the top, and the reason the toolpath is under is because I have to do this minus 2 thou 5/10, 2.5 thou, because the fixture is actually overcut. I ended up shrinking the thickness on the lock bar, but I had already cut the fixture and it's a pocket, so what I'm having to do is just cut below, and the model doesn't represent the shortened pocket anymore, so that's why we're just cutting below, so you can kind of just ignore what I just said. So we're going to finish, and what we're left with is, the cool thing is with this new in-process stock from Fusion, we're left with this these 2 bolts and these 2 caps still holding the workpiece. I haven't mentioned the tabs. There are tabs that are very important. These tabs, that is critical, obviously. So we have tabs. The tabs then are held down with the 440s. Finally, the last one is we have a mini clamp that I've built out of chromoly, and these use 256 screws because we're starting to get tiny here. What we're left with is the lock bar itself, the tabs, and these 2 pieces of stock from holding the op 2. So what we do is first we're going to come in with a 1/8, excuse me, a 1/16. I could probably just come in here and sweep it with a 1/8 or the tool, but I just use tool 1 for this entire op, that way there's no tool change. Get rid of those, we're left with the tabs. We're going to adaptive away the tabs, adaptive that tab, adaptive the pocket that's here, and again I have that stock to leave in a negative because of the fixture. Finally, we're just doing cleanup contours. So there's a contour, it runs right here, this contour runs this pocket, this contour runs that pocket. There's a contour here, which I need to remember to leave 5 thou because that was my plan. Contour that little section, and then finally a chamfer, and we're done. So let's go back into the real world. Oh, lots of yawning. I swear I wasn't crying. Okay. So, this is the stock that I'm talking about. It's heat treated. It's 174H900. H900 just means it was treated to 900 degrees, which is in the like 30 Rockwell C, I think, range. Or maybe it's 40. 40, 30, I mean, it's important, but you can look up if you're really curious. So we take our stock, and let me switch you guys here. Try not to move too fast because of motion sickness. So we take our stock, and our stock's going to go right here, butt up against this clamp I was telling you about. So this clamp is permanently fixed to the fixture, and then we have the, what did I say, pitbull or talon? Or these things called? Yeah, Pipple. It's Pipple, so we're going to crank that down. Let me grab my Allen keys without making anybody sick. Where? Okay, hold on. Okay. So, take your nice Allen key. The important thing with the pit bulls is you actually need this back shoulder on the pit bull. Somebody messaged me on Instagram and told me I was dumb. Well, he didn't. He was very nice. But the back shoulder is very important, and we were talking about another fixture I'd made, and this one already had the back shoulder, but that's kind of an important aspect of the pit bull. I won't get into how they work because well, I really don't understand how they work. Well, I understand how they work. It's a clamp. The cool thing about the pit bulls, though, compared to the other stuff, is it actually forces the material downwards. It kind of it's got this downward action, and the cool thing is it's really strong. Like I'll show you the feed rates we're running this, we're cutting this thing at, but it works incredibly well. So yeah, that's set in place, and then we're gonna do our adaptive, and money will fly out of the spindle. Okay, so this is the tool we're gonna rough out with. It's at that's at 3/16 Alton corner radius. I think it's 10 thou or 15 thou. I want to say it's 15 thou corner radius with air blast, and I'm running this thing 5% step over, which I couldn't tell you what that is. I think it's 9 thou and 80 inches per minute. So it's pretty impressive, honestly. What a little bit of air blast will do. Before, these took 9 minutes to rough it out, and now it takes 2 minutes. It's awesome. But hopefully we don't crash on the corner there. I won't show the whole thing, but I'll just show you the cool bits. Image stabilization working really hard. So yeah, you kind of get the idea. Cool, so here's op 1 done. You can see roughed out. We got the little sliver. Very hard to tell. I assure you there's a sliver there. It's this camera. I think I need to get a different lens for this thing. But yeah, so we'll take that and we'll flip it into this shape and we'll bolt it down right here. And yeah. Alright, here's op 2. Like I said, take the 440s, we bolt through those through holes. Here's that little burr I was telling you about with the pocket. Kind of hard to see, but yeah, see it's still stock here because it's a burr, and instead of like filing down, this is just way quicker to leave a pocket here because it's going to get ripped off when we do this adaptive. And you know, we'll adaptive and yeah, we'll just go through it. Look at those beautiful chips flying away. So you get the idea. Alright, cool. This is what we're left with. There's that burr right here. I'm probably about to cut myself. So yeah, just tear that off. Well, you get the idea. And then we'll install the clamp on these little holes here, clamp it down, take the bolts out, then rough out and finish, cut all the tabs for op 3. Alright, here it is set up. Two 440s removed, two 256s and the tiny baby clamp installed. We'll come in here, destroy these two things, and then adaptive clear the little pockets, like remove the tabs, and then adaptive clear the tab downwards, and contour this thing out, and we'll have a lock bar. Alright, there it is, done. Focus. What are you focusing on? Rather frustrating. Kind of hard to tell, but I will take it out. But clips are gone, I mean the tabs are gone, and yeah. So, that's what it looks like off the machine. Burrs and stuff all over it. So, I'll clean it up, and then we'll put it on the knife and see if the lockup is improved. Alright. Welcome to the install portion of the video. I'm your host. Okay, so we need tools, of course. So I replaced these screws with those countersunk screws. Oh, sorry. With these nice titanium, what do you call them? Button head cap screws? But I find that tightening the handle down is kind of a pain with them installed, so I need to come up with something a little bit better to make the user removing experience better, if you will. Yeah, they're a pain. Right now I have to use two Torx bits on both sides to get them unscrewed, which is to me not too acceptable, but you know, when hopefully Nick Shabazz in the future reviews this thing and he can't unscrew it without getting two screwdrivers or Torx drivers, it's going to be kind of awkward. So, that's that. Take this thing apart. Here's what the handle looks like. That's one installed. Oops, sorry. The viewfinder's upside down, that's why. So this one's not good, it's too short. So hopefully our new one is better. Let's see if I can compare them. Kind of hard to tell. I mean, I only left 5 thou, so... Yep, this one does look a little bit longer. I don't think you're going to be able to see it, but... Yeah, you're not going to be able to see it. It just overhangs the bottom handle. The bottom handle just slightly, and that's kind of what I want. I want the steel to only be touching the blade and no titanium, and that's kind of the whole point of this system. Very tiny screw. There it is, the new one installed. So we will give this a shot. Yeah, I can tell. Oh, might be pretty good. Hold on. Let's get our... Yeah, these screws are nice, but they were not cheap. Over $1 a piece, and there's 4 of them on this thing. Too bad I don't have a Swiss lathe. Alright, so Oh, that's much better. See, no more play. Oh yeah, way better. That's awesome. Almost perfect. There's a little bit of lock stick. That's what that noise is, but hopefully over time it'll be it'll wear itself in properly. So yeah. Alright guys, thanks for watching. If you like this, sub of course, leave a comment. I try to respond to the comments if I see them. If you comment and I don't comment back, it's very likely I didn't see it. If you want to reach me directly, Instagram's a good way. It's the same username as here on YouTube. And yeah, so this is where we're at. This is very close to drop shut, which is awesome. So I'm turning the pivot on the mill. I'm not turning it, I'm, interpolating it. So it's not like a dead perfect circle compared to like a lathe could give you. So just to get this kind of action on a mill is pretty good, honestly. So yeah, things are looking very good. And I'm even making the pivot screw. 664 threads, that's not a common thread, so that took me a couple days to figure out. But so yeah, like I said, thanks for watching, and have a good one.